Welcome to CWP. In the last video, we learned how a machine learning model improves using gradient descent. It makes a prediction, calculate the error, check the slope, adjust, and repeat. But here, today, here's the real question. So, how big should the model adjust? How big should the adjustment be? Should the model take a huge jump? Or just a teeny little bitty steps? That's right. It is called the learning rate, all right? And today I'm going to explain in the simplest way, okay? We're not gonna, no scary math, don't worry. It's just a way to kind of like get you started. Understand really what learning rate is about. So remember our mountain example. You're standing at the top of a mountain in darkness. Now, the top is the worst model, right? Which is where every model starts from. And then the bottom is like the best model, which is the lowest error, right? Gradient descent tells you which direction to go. Go up, go down, go right, go left, whatever. But it doesn't tell you how big your step should be. That decision is controlled by something we call the learning rate, which is what we're talking about today. Now, let's get right into it. What is learning rate? Now, learning rate simply means how big a step the model takes when adjusting itself. Does that make sense? That is, big step, small step. Should we take a big step? Should we take a small step? That's basically what that is. If we look at this, we can see that we have big step, small step, and we have just right step. If you take a big step, it's a no-no. When the step is too big, it's a no-no. When the step is too small, it's actually cool, but it's just gonna be too slow. But if your step is just right, then you're working like a boss. Does that make sense? You can see this learning rate right here. We talked about this, right? Remember? This number right here is what controls the step. All right? Okay? Just don't think too much about it. Don't worry. That's why we're here. We're going to explain that. Okay? But I'm just going to go ahead and close that first of all. Look at this man right here. You jump past the lowest point. Now, you see, it just jumped. And what happened? It jumped past the lowest point and you're trying to come back to the lowest point. That's what it is. Now, another thing is that you bounce back and forth. When we take a look at this, when you take a big jump, this is what happened. You just bounce back and forth. You're not actually getting a particular point that you need to get to. And you really need to get to that particular point. You need to follow the slope all the way down. That's what happened when you jump. I'm going to go over it again. When you jump too much, one of those things happen, right? The very first one is you overshoot the bottom. That means you're not passing. First, your jump, you're just passing up the bottom. Number two is you jump past the lowest point. Number three, you bounce back and forth, just like you see this ball bouncing back and forth. Number four is you never settle down. It's just back, forth, going up, down, up, left, right, just like this, right? Now, it never reaches the best model. This is what we call the not conversion in a simple word in machine learning, okay? All right, so if we have that, right, this means that the motor cannot calm down and learn properly. It's just all over the place. That's what it means. Now, let's talk about if the rate is too small. If the rate is too small, I want you to imagine this little tiny step right here. You can see it is going to be very, very slow. Yes, you're going down, of course, but it's going to take forever, and nobody wants that. Okay, nobody wants that. It's going to take thousands, millions, billions of steps, and don't nobody have time for that. If you're working with a very big data sets, can take you billions, and that's just the model learns, yeah, but very, very slow, and that's just a waste of time and computation. You don't want that at all. Now, I want you to take a look at this. You take steps that are not too big and not too small, but just right. Look how smoothly it goes down from the top, and it just goes all the way down learn and go to the slope. Instead of bouncing up and down or being too slow, it just goes automatically to the point it's supposed to be, going from up all the way down. Okay, that's the best. That's what you really want. That's the perfect learning rate we are looking for. And when this happens, that's when training becomes stable and efficient. All right. Every real AI model coming from your chat system, recommendation engine, fraud detection, self-driving cars, face recognition, all of them uses gradient descent, okay? And all of them depend on choosing the right learning rate. Now, if it's too big, just like I explained to you, it means that the model is unstable. If it is too small, the model is slow. The just right, which is the one you currently have right now, means that the model improves beautifully. Okay? So when we look at this graph right here, I want you to take notes. You're going to see that the green one is your normal step, the red one is your overshooting, and the blue right here is the slow model. Let's go there and run it. Now you can see them running in iteration. You can see the green going very smoothly and come down. It got to the final destination before the other ones, right? And when we take it again, and you can see that the red is just jumping up and down. It's not even following the curve at all. Yes, the slow one is following the curve, but it's just extremely too slow and it's not consistent. So you can see that right here, the green is just the perfect slope, learning everything and grabbing it and just being there. Now, if you notice somewhere, you can see that the green went up a little bit and come back. We're going to talk about that later. This is that particular section right there. That particular section, when this happened, something is called, right, in machine learning, but I just don't want to give you a lot of information right now. We're going to take it one step at a time. All right. So in general, what are we talking about when we talk about learning rates? I want you to know learning rate is equals to the step size. Too big is jumping around. Too small is like, it's just too slow. Perfect size is the smooth learning. Now, gradient descent tells the direction, while learning rate tells the step size. Don't forget that. Altogether, they all help us to actually, make the model learn efficiently. Does that make sense? Now you can be proud of yourself, saying you understand not just gradient descent that we did the last class, but what controls how fast and how well it works. In the next video, we're going to talk about even something very much more interesting: why a model can become too good at learning or training data. With that being said, if you have any question, put in the comment section. If you have, you like this video, please go ahead and subscribe to this channel so you can get more contents like this. Don't forget to go back to other videos. This is a series to becoming AI machine learning engineer. We follow all the way from scratch, okay? Follow the rest of the video, go to the Python playlist and follow from scratch and build your way all the way up here, all right? With that being said, I'll talk to you guys later. Happy learning rate. Bye for now.